Okay, so this is special functions. We were graphing. This is the piecewise function. We have f of x is equal to 3x, where x is less than -1, negative x, where -1 is less than or equal to x less than 3, and negative x plus 7, where x is greater than 3. Then we're going to identify the domain and the range. So, as it is piecewise, let's kind of take this piecemeal. And here's the best way to kind of graph this. So, first of all, as you know, f of x is the same thing as y. So you think of this as y is 3x. So what does that graph look like? Well, here is y equals 3x. So you have your line. Since this is just 3x, you have no y-intercept, which you can think of as 0. It goes through 0, and you have the slope of up 3 over 1. Up 3 over 1. So here's your line. Next, you have f of x is equal to negative x. So you have the line we've already graphed, and then y equals negative x. So again, we have no x-intercept, meaning it is 0. So plus 0 would be here. So we go through 0, and it is down 1 over 1, down 1 to the right 1, and we continue that pattern. We can go up 1 and to the left, up 1 to the left, and so here is the y equals negative x line. Lastly, we had f of x was equal to negative x plus 7. So this third line, we've got our two existing lines. We just have them dashed in. We'll make them more permanent here in a second. We have our portions. So we have y equals negative x plus 7. So plus 7, here's our y-intercept. And then our slope is negative 1 over 1. We can put that in there. So down 1 to the right 1, down 1 to the right 1. And we continue, and we have all three of our lines now dashed in. And we need to decide what portions are we keeping. So let's go back and think about our very first line. So we have y equals 3x. And we also had, at the beginning, all three of these. We had f of x, and we had these kind of requirements. So we had 3x, x is less than negative 1. So as far as our graph is concerned, x is less than negative 1. So here's this line that goes through 0 with a slope of 3. We go and find where x is negative 1. So we come along our x-axis. Here's our negative 1. We move along our line until we get to the x negative 1. So we come down here. Here's where, on this line, x is negative 1. And that's where I want to begin to keep. And it says less than. So here is less than negative 1 as far as our x-axis is concerned. So that will be to the left. So here's our negative 1, less than, so that will be an open circle. And so we keep this portion of the line. So this is permanent. Our next line was the negative x. We had negative 1 less than or equal to x less than 3. So let's look at all of this portion. So y equals negative x. And we went from negative 1 to 3. So looking at this line that was through 0 and had a slope of negative 1, looking along our x-axis, because that is what we're concerned with, the x, and we find negative 1 and we find 3. So here is negative 1. And we come along negative 1 on the x, and we find it on our line. We come along 3 and we find it on our line. And this is the portion on this line that we want to keep. Well, at negative 1, we have a closed circle. At 3, we have an open circle. And this is the portion we keep. If the closed circle and the open circle, we'll make this permanent. And then, to finalize this graph, we have everything penciled in. Let's get the right graph. That would make it better. We have everything penciled in. So we have done these two lines. Our last line is the negative x plus 7, and then x is greater than 3. So we have this highlighted. So we've done these two portions that we've made permanent. And here's our final line. So our positive 7, our slope is negative 1. We want x greater than 3. So coming along here, here's our 3. If we come to our line, which is graphed, here is where on the line we have an x value of 3. And so for an x value of 3 and it's greater than 3, here is everything greater than 3 on the x-axis. It is to the right. So everything to the right along this line is along this way. So here's to the right, I'll put everything to the right on this line. So my open circle here, because it's greater than, make my open circle, I'm going to make this portion of the line permanent. And that is how I go about graphing all of these. So dot in your lines, you can erase everything that's dotted, you can leave the stuff that is dotted, but then after we have all of our lines graphed, then we can go back in and take care of these kind of requirements. This is what I'm keeping, this is the portion that you want to have. Now we can talk about what was our domain. So looking at this final graph, domain, we're looking at our x values. So decreasing along the x, increasing along the x. Look at all these portions. Okay, so I have between 1 and 3. I don't actually have a 3 value because it's open. I do actually have a negative 1 value because it includes negative 1 here on this portion of the middle line, kind of the middle. I don't have a negative 1 here on this line that was 3x, but I did have a negative 1 here. But this is going to continue to decrease. It's over here on my left, and it does continue to decrease. It's expanding this way. This portion, this line, is going to continue to increase as far as x values because I'm moving to the right. Here I'm moving to the left. I'm getting more and more small x values. I'm getting more and more larger x values. However, did I ever have a value of 3? No, I never had a value of 3. Because this is an open circle or an open circle. I did have this negative 1 because I had a closed circle. So our domain is all the real numbers, but x was never equal to negative 3. And that was because of the open circle that I continued to have here. So I never had that 3 on either one of these lines. Now our range, this line continues to decrease as far as our y values are concerned. And then we're looking as we increase up and as we decrease down. This line, of course, stops between negative 1 and 3, so we're kind of done there. Or excuse me, negative 1 and negative 3 is going here. And then this line continues to decrease as we continue down in our negative y direction. And this line continues to decrease down in the negative y direction. So we're going to continue to go down, 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 down. So there's never a point that we do not get below this value, which is a 4 if we were to plot this point. But do we have any graph up here that we have kept? No, we don't. So what would our range be? Everything below this point? Yes, everything below that point. So our range is y is less than 4. And that is our domain range. So continuing to look what is happening to the left and to the right along our x values. What is continuing to happen up and down as far as our y values. We had another kind of odd function to graph, and that was our greatest integer function. So we have some new notation. So f of x equal to, and these double brackets, greatest integer. So each decimal or mixed number has a greatest integer value of the previous integer. The integer less than or equal to x is the other way to think of it. So the greatest integer value of negative 2.6 is negative 3. That is the previous integer, the one that was less than or equal to this x value. And then, of course, the positive integers are a little more easy to think of. 4.5, the greatest integer of 4.5 is 4. So its previous integer was 4. And the graph appears as many horizontal line segments. And we arrive at these horizontal lines, and here is just kind of some highlighted values. Right here, if I put in an x value of 4, then I'm going to get out a y value of 4. If I put in an x value of 4.3, I'm going to get out a y value of 4. If I put in an x value of 4.9, my greatest integer, I'm still going to get out a value of 4. So your y value stays unchanged no matter what x value of 4.1, 4.15, 4.2. You're still going to get a 4. Of course, you never reach 5 because your greatest integer is the previous integer. And so we have closed circle,